Hello, my name is Bianca Possamai, and I'm very thankful for this opportunity to be introducing myself and my research plan that is entitled Using Latitudinal Patterns to inform climate change effective food webs organization in the South Atlantic Ocean, an ecosystem approach to support management efforts. Just to give a brief overview of my career path, in 2012, I got my bachelor degree in oceanography, and then in 2015, but with the same university, I got my master's in all the cases working with fish diets and trophic interactions. In 2019, I got my PhD, and during my thesis, I worked in a long-term ecological research program. And I use the data from this program to investigate how climate events affect trophic interactions and ecosystem attributes. My thesis resulted in 4 papers that very much translate my main interests in research and also a strong and lasting collaboration with my PhD advisor. After defending my PhD, I kept working in the monitoring program for a while, and then I was able to assume a postdoctoral position in the United States at Baylor University, and later I moved to another position more aligned to my goals in the University of Vermont, where I am currently in. Here I am evaluating habitats as hotspots of productivity, influencing offshore areas of deep lakes, and also exploring effects of stressor in food webs. After 5 years of postdoctoral experience, I feel ready to go back to Brazil and pursue a permanent position as a professor in research. By using spatial and temporal ecosystemic approach, I will untangle food web patterns in the latitudinal gradient and predict ecosystem responses to environmental fluctuations to take actions for protecting ecosystem function services, especially with the current climate change scenarios. Extreme climatic events are more frequent and intense due to climate change, with several consequences to ecosystems, such as biodiversity loss, invasive species, and loss of ecosystem services. So finding biological hotspots and understand the role supporting adjacent ecosystems is fundamental to protect ecosystem functions and services. Mangroves, salt marshes, coral, and rock reefs are examples of biological hotspots because they have higher productivity and furnish all this energy to adjacent systems, but they are severely threatened by human uses and climate change. For example, 40% of wetlands and mangroves worldwide are not protected by any environmental conservation laws, and most of the reef areas have unknown status. But they provide coastal protection from waves, storms, and other natural hazards, and also sustain many fisheries around the globe. It's fundamental to understand the role of the systems in supporting the fishery stocks and biodiversity to provide the real and updated information to decision makers to establish priority areas for conservation. One consequence of climate change that is affecting marine ecosystems is the tropicalization, a process where the species are expanding their latitudinal range due to increasing optimal temperature range. Many examples of this process are already reported in the North Hemisphere, especially in tropical species affecting temperate ecosystems, including trophic cascades, leading to shifts in the entire ecosystem. However, evidence of tropicalization in the south are still poorly investigated. The Brazilian coast is a perfect model to understand these trends because it runs from tropical areas, passing by subtropical ecosystems and ending in temperate-like ecosystems. One of my ongoing research, we investigate latitudinal patterns on carbon assimilation within estuaries using the Brazilian coast as a model, sampling from Pará to Rio Grande do Sul, and also Uruguay waters to understand in these shifts. And we found out that latitude and productivity are the two main drivers of shifts in energy sources supporting the systems. Productivity is affected by climate change, and so understanding the latitudinal patterns in productivity and the influences on the energy flow along this latitudinal gradient, it's important to inform predictive models to the potential disturbances of tropicalization and food webs. So for this plan, I started with 4 initial hypotheses to be investigated. The first one is that the carbon exported from the hotspots will sustain the marine resources. The second is that the climate change is impacting negatively the carbon flow between the hotspots and the recipient systems, and so the recipient systems will be relying on autochthonous production. The third hypothesis is the species range expansion is occurring and is impacting especially subtropical and temperate systems. And the fourth hypothesis is that disturbances in food web organization is stronger in subtropical and temperate systems compared to tropical systems. So, to investigate the first and second hypothesis, I'm proposing 3 main objectives, being the first, evaluating latitudinal patterns in food web organization in the South Atlantic coast. 2, estimate energy transfer within and between marine and coastal systems. And the third is to assess the role of mangroves, reefs, and salt marshes, our biological hotspots, as energy donors to adjacent habitats. To complete these objectives and test the hypothesis, a combination of techniques will be used to evaluate food web's relationships and latitudinal patterns, including stable isotope techniques to evaluate energy flow and connectivity, molecular analysis of stomach contents to distinguish herbivorous diets, for example, and stomach contents analysis for carnivore species. Mangrove, salt marshes, coral and rock reefs, sand beaches, and also offshore habitats will be sampled in the entire latitudinal range of this proposal. Different coastal systems will be sampled and also offshore areas in our latitudinal range of distribution. We will collect different components of the food webs, including benthic planktonic producers and consumers at different trophic levels. Non-lethal methods of tissue sample will be preferred for fish species, and also we will be collecting abiotic data during all sampling campaigns. In the context of this proposal, I'm calling from 0 to 20 degrees south of latitude, a tropical zone, because just following the coral reefs distribution, from 20 to 28 a subtropical, following the mangrove range of distribution, and higher than 28 a temperate zone, because our area is dominated by wetlands and salt marshes. I have collaborations in all the zones that can facilitate the field work and the laboratory processing, and I will also pursue increasing the latitudinal coverage with new collaborations, focusing especially in temperate and tropical zones. To evaluate the third hypothesis of tropicalization occurrence and its impact on subtropical systems, I will lead a monitoring program in different habitats of the São Paulo coast. The ichthyofauna will be monthly collected in coastal habitats, including mangroves and sand beaches, using common gear. Fish will be measured, identified in the field, and then released to the environment. For the rock habitats, seasonal sampling will be conducted, and the team will use visual sensors by snorkeling and also video recording using the Transect method. And then the videos will be later analyzed in the laboratory. To complement the surveys, water will be sampled every 2 months for the eDNA analysis, focusing on fish and macroinvertebrates detection. Also, we will always collect abiotic data using a multi-parameter sound, and this data will be feeding a long-term database. To test hypotheses 3 and 4, we use the data from the monitoring program, the food webs, latitudinal approach, carbon flow. All this information collected throughout the time of this project will be used to inform food web models, and also these models will be related to environmental data, so then we'll be able to predict scenarios. And also, for example, understand how this invasive species due to tropicalization will affect subtropical and temperate zones. Previous work of researchers from São Paulo State predicted that subtropical reefs will increase diversity of herbivores, while tropical ones will lose species, and there will be an overall homogenization and species in the near future. My research plan expands this approach by evaluating not only one trophic group effect on the ecosystem, but different relationships between invader and native species, and how this will play in different seascapes and in the latitudinal range. In summary, my research plan proposed to use an ecosystemic approach, monitoring ecosystem process and how they vary depending on environmental changes, which is critical to understand how climate change will affect differently coastal ecosystems in the South Atlantic and how this effect will translate in connectivity between the coastal and offshore systems. Tropical species are likely migrating to the south in the South Atlantic Ocean, and so understanding their connections in the native range will inform their responses in the higher latitudes. This proposal may lead to management practices such as development of new fisheries targeting the range-expanding invaders, and also monitor the evolution of ecosystems to evaluate of the best options and best conservation practices. Thank you very much for the opportunity to present my research plan, and I hope you find it as important and as interesting as I find it. I know it's a very ambitious plan, but I have previous experience with monitoring programs, working with all these techniques, and also with the latitudinal patterns, have collaborations, and also I will hire a very good team that will help me in all the steps of this research. Thank you very much.